Hi everyone and welcome to Island Math. Today we're going to be looking at estimation, rounding, and percentage error. First of all, you'll need to know your place values. Here is an excellent chart for looking at the place values that they will be asking you about in the exam. You can pause the video if you'd like to look at this because this is definitely a good refresher. So for rounding, first we'll have to look at the rules. So usually they will ask you to round to a specific place value. So let's say they ask you to round to the nearest 10 on a number like 376. First, you find that value, that place value. So the 7 is in the tens place. And whether it's rounded up or down is dependent on the number to the right of the value that you're actually rounding up or down. So that would be the ones place in this case. So the rule is if that number to the right of the one that you're actually rounding up or down is 5 or above, you will round up, and if it's 4 or below, this includes the number 0, 4 or below, you're going to be rounding down. And so for this number, since 6 is obviously above 5, our rounding is going to make the tens place go up 1. So when you're rounding up, that number goes up 1, and then all other numbers to the right of it will be turned to 0. So we get 380. Now, if there was another number such as 374, very similar, however, this number is in fact 4 in the ones place. So we would have to round down, and that would give us 370. When rounding down, the number in question basically just stays the same. So the tens place, which is the 7, it just remains the same. And all numbers afterwards become 0 once again. And that is the basics of the rounding rules. Now we can look at some questions. First, we're going to be looking at this one right here. So working out an estimate for this value, first we're going to have to basically figure out what we're rounding because they didn't tell you what to round. So in these kinds of questions, they basically want to see that you know how to round and how to take a good estimate. So a good estimate gives you easy to use values, but it doesn't go too far away from the numbers that they originally gave you. So for instance, in this question, we start out with 647. We are not going to round to the nearest 100 because that's going to give us 600, which is far off from 647. So we're going to round to the nearest 10, and that's going to give us 600, and the 4 is going to round up since the next number is 7, which is greater than 5. So 650. For the denominator, we have 4.8. We can round that safely up to 5. And we have 9.7. We could round that safely up to 10. And then we get these values here. 650 divided by 50. And this is in fact equal to 13. If you want to test it, you can do the long division. Simply 150 minus 150. 50 times 3 is 150. That gives you 150 and 0. So 13 with no remainder. And so your estimate for this would be 13. This is not the exact number, it's just an estimate. However, that's what they want to see you do. They don't want you to put it in the calculator and then round up or down because you're not going to get the correct number that they are looking for. Now, for a question like this one, we're going to be rounding 6,500 and we're actually going to be rounding 5,000, 763 to the nearest 10. So we're just going to write out our digits until we get to the tens place. 5,000, 7, and now we're to the tens place. So the number in the tens place is a 6. So we know that either it's going to round up to 7 or it's going to stay at 6. Our number here is 3 in the ones place, and since 3 is 4 below, then we're just going to leave it at 6. So 6 and everything afterwards is 0. This is going to be our final answer, nothing too difficult. For this question now, rounding 2.5718 to the nearest thousandth. Now, the thousands place is, if we had like a number like 2000, it's going to be here. The thousandths place, tens, hundredths, thousands. The 1 is in the thousandths place. So what we do is we just keep writing our number until we get there. Tenths, hundredths, and the thousandths is going to be where the 1 is. We have to figure out whether we're rounding up or down, and that depends on the number to the right, which is the 8, and that's actually in the 10,000ths place, the 10,000ths. So since that number is greater than 5, we'll have to be rounding that 1 up, and we get this as our answer. Now, we're not going to add a 0 at the end because since it's already in decimal form, any extra zeros are just going to be null and void. Won't really count. So our final answer is going to be 2.572. Next, we're going to be looking at the final question, which is this one right here. 2.023 cubed, divided by 1.97 squared. Well, we are obviously not going to be able to find the exact answer without a calculator, so we just look at the number 2.023. Since we're cubing it, it probably makes sense to round it to a whole number, which 2 is not too far off from 2.023. So we're going to round that up. We get 2 cubed divided by, for our denominator, same type of deal. We have to square a number, and it's probably going to be uncomfortable to square anything like 1.98 or anything of the sort. So we're going to round this up to 2 as well. So basically we get 2 cubed over 2 squared, which is the same as 2. If you want to calculate that out, that is 2 multiplied by 2 multiplied by 2 divided by 2 multiplied by 2, which is 8 over 4, which is equal to 2. These are basically how you would solve these kinds of rounding and estimation questions. And once you follow the rules and find adequate estimates that don't go too far away from the original value they gave you, you'll always be getting these right since they mark with a range of values for you. Now let's look at the percentage error. Percentage error questions are very specific. They will always include some phrase in which they ask you find the percentage error or find the margin of error between these two values. So the percentage error is calculated, as you can see over here, by taking the value of the measured subtracted from the real divided by the real value. And on the next slide, I'll be showing you what this actually means. And then you'll be multiplying that by 100 to get it into percent. So as we go to the next slide, we can sort of see what this equation is talking about now. So Johnny calculates from an experiment that he has 22.7 grams of carbon. So the estimate is 22.7. And as we look now, we're just going to go back to this. We can see that the measured value, so this estimate is basically his measured value. So the measured or estimate is 22.7, and now we're looking at the real value. However, he should have gotten 21.8 grams of carbon. So our real value is going to be 21.8 grams. And that's the accepted value. And they're asking, what was his percent error? So we can calculate his percent error now by saying the estimated value minus the real value divided by the real value. And as we can see, this is what our equation is saying, measured minus real divided by real, multiplied all by 100%. So we're going to have to multiply 100% multiplied by whatever the result of this is. And so if we do that calculation on our calculators, we're going to get 22.7 minus 21.8, that's 0.9. So 0.9 divided by 21.8 multiplied by 100%, we're going to get 0.04 approximately. We wouldn't have to go any further than that. And when we multiply our 100% by this, we get approximately 4% as our percentage error for this question. And we can also go on to the next question and do a similar thing. So a person estimates that 2,000 is spent on travel expenses for a particular trip. So always think about it in terms of measured and real or estimated and real. So always remember the equation. So estimated was 2,000. Subtract from 2,250 since that was the real cost. And we're going to then finally divide all of this by the real cost. And one thing to remember is that the number for your numerator is going to be the absolute value. You're going to take the absolute value of that. So whether we get a negative number or positive numbers besides the point, we're always going to make that positive in the end so that we can get a positive percentage. So when we do 2,000 minus 2,250, we simply get negative 250, which is going to be switched to positive since it's the absolute value. And we are dividing that by 2,250. And if we do this calculation, we get 0.1 recurring, but always remember to multiply that final number by 100% in order to get your final answer. So what ends up happening is our final answer, we just move the decimal point over 2 times. We get 11.11%. Of course, the actual answer is 11.11 recurring percent, but for exam purposes, you're not going to leave the recurring in the decimal, in the percentage, sorry. You're just going to keep it at 0.11 because the other values are less significant, and this is the approximate percentage error. And once you follow the methods shown in this video for all of these questions, you should be able to calculate all of these. Just remember that when you calculate the measured value minus the real value, always use the absolute value. Always remember to use whatever place value they tell you to round to. If they tell you to round to tens, to thousandths, whatever, you have to round to that exact value, and you use the value to the right to determine whether you're rounding up or down. And for estimates, always remember to choose place values to round up or down that aren't going to give you an estimate that is too far off from what the original value that they gave you was. I hope this video was helpful, and I hope to see you in the next one.